Hey everybody, this is Larry. This is day 29th of the September Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me in Discord, let me know what you think about this one. So I did solve this one live. I think the code is ugly, very ugly. So I don't even know if I'm gonna go over the code that much, but I just want to go over the idea behind this problem, right? Because, well, the video is very long, so there's a little bit of an intro for a summary. You can certainly watch the live portion afterwards and feel free to do so. But I just want to give you a little bit of context. Okay, so for this one, we have insert, decrease, or increment, decrement, get max, and get min, right? So really, honestly, the core part about this problem is just figuring out what you have to do to go through them, and also the cases that comes up is really all there is. And here I'm going to bring up my drawing thing. Hang on. Right. And you could kind of see my progression if you like, but basically when it comes down to it, there are a couple of things. Right? You have to maintain max. So there's a thing that you want to do for max, and the max, there is some increment and decrementing of stuff. So you're incrementing things that's go through time. It can only happen through incrementing, right? Because that you get a new max, and of course, if you decrement, then it just goes down. But if you have multiple numbers, then it depends on how you want to handle it, right? So max is very easy because there's no jumps, right? The max will always go up or down by 1 at most, and that's it, right? When does it go up? It goes up when you have a new max, right? And it can only go from max to max plus 1, right? And it can only go from max to max minus 1, as we said, and it goes to plus 1 in a very obvious way, I hope, which is that when you have a number that's already at max count and you increment it, right? And then now the decrement is a little bit trickier, but not by that much. I think you can solve this problem. And I said it later on, but this is basically a bookkeeping problem. Bookkeeping is not an algorithm or anything. It's just basically pretend you're an accountant or someone with money, and you're just trying to make sure that all the books are balanced and kept so that you know where everything is exactly, right? And that's basically it. The max minus 1 is also conceptually straightforward. It's just that you have to maybe keep track of the number of things that were previously max, and then when they all get removed, then you know that it's going to be max minus 1. And it always has to be max minus 1 because you only decrement 1 at a time anyway, right? So this is max. Really straightforward. I don't think, yeah, that's it. Min is a little bit trickier, right? So min is the thing that I struggle with a lot. I think algorithmically I had it pretty early, and you could see this in the video. It's just that I was too lazy to implement it, and once I implemented it, I was like, fine, and then you have to go for all the cases. But okay, so what are we doing for min, right? So for min, double check that it's on the screen. Okay, so for min, actually, basically there are a couple of cases, right? Let's say this is at 0. You go from 0 to 1 when you insert a new key, and then maybe you increment it, but then next, when you insert a new key, it also goes back to 1, right? So now it jumps straight down to 1 again, right? And then it goes down, it's possible for you to use decrement, so it only goes down 1, but you have to keep track of all these things, right? And sometimes it just goes straight down to 1 again, right? And also the other thing, so there are two cases, or two trick cases, right? One is that when you insert a new key, terrible handwriting, which is why I don't write this mantra, it has a value of 1, and that value of 1 will be the new min, right? Okay. And then the other thing is, of course, when you remove this, so let's say you have here, then you remove that value, well, your new min is not actually at 0, right? It's whatever's on top of it, or the next min, right? And so then it can actually also jump very high, very quickly, right? So that's basically the tricky part, is that, yeah, and then here is delete a min key from 1 to 0, right? So that's basically the idea, and the idea here is that what do you want to do, right? Well, There are a couple of ideas. The first is maybe we can just keep track of everything in a heap, right? We just kind of always get them in because we use a min heap. We always get them in. We're pretty good, right? The only problem with that is that for this problem, and yes, you can get an AC or get it accepted without the optimal complexity, but it's up to you to really test yourself, right? Like at the end of the day, you're the person who's solving it. And here, and we're using a heap, it's going to be log n, and it's not going to be O of 1, right? So then now, what are we doing, right? Well, let's actually, the way that I thought about it is that, okay, let's say we have a sorted list of everything, right? Then what would it look like? Okay. Let's say maybe, we go, this is a sorted list. Let's say we insert a new value, it's going to be 1. Maybe you increment, and then it's going to be 2. Yeah, I don't know if there's a cleaner way to do this, right? But yeah, maybe now you add 1, it goes to 2. You add it again, it goes to 3, and then maybe it goes all the way to 5, right? And this is your min because this is your only element. Then next you add 1, right? And then now you have 1, so then now that is obviously the new min. You increment, and then so forth. Maybe you keep on adding other numbers as well. And you want to keep this sorted, and maybe this thing for now, just for whatever, right? And then now it goes from 2 to 1. To 1, and then to 0, and then you pop it off, right? Because, well, now your new min is 5. So basically, so there are two things, right? One is that, remember, once again, we're only incrementing, right? So let's say we have a list like we have now. If we're incrementing, yeah, wait, why did I do it the way that I did? Yeah, okay. But yeah, so another way to think about it is that, you're only incrementing. So here, when you get rid of this, you get rid of this, right? So yeah, the only operation that you're doing is incrementing. And what I mean by that is that, let's say you want to increment whatever the key is that is at 9, you can, increment it to 10, right? And then maybe increment this, it goes to 11, and now you add it again, and then there's a 12. There's two things at 11, so that's why we don't remove it, and so forth, right? But if you kind of do it this way, well, how would you do it in O of 1 time, right? So that's basically the key thing, is that you have all these shift things, and you only care about two operations, really, right? One is to get them in, right? To get them in, which is in front of this list. And then the second is maybe a find function to find a node, but you don't care about where it is. You just have to find a given node and then do things, right? Oh, I gave it up a little bit. But yeah, and it turns out that the way to think about this, at least in O of 1 time, is by using a linked list, because we're doing arbitrary deletions and adds, and all we care about is the beginning of the list. So here you can think about it as, okay, so now you have a node, right? It points to another node that has a 1, points to a 5, points to a 6, point to a 9, right? Or I guess I deleted the 9, but whatever, right? And then now let me delete some stuff so it's a little bit clearer, because this arrow is kind of confusing. Yeah, now we can increment, right? So increment, and then now maybe increment this to a 4, and then if you want to increment this again, maybe you just merge the nodes, right? Because now you have 5, 5, and then you kind of merge the nodes somehow, maybe by deleting. So then now this points here, right? Yeah, and then same with decrementing and stuff. The beautiful part about this is that when you decrement, say, when you decrement, right? Like let's say you have 4, 3, 2, 1, right? And then now you're removing it, or You can do this in all at one time. Just make a new pointer and you get the next immediate min value. So that's basically the way that I thought about it, is that it allows you to get the min value in all one, because everything is just shifting left and right, right? For example, like if this 6 becomes 7, then 8, then 9, then 10, then maybe this just, it's just about a linked list of creating a 10 node instead of here, right? Very basic things, and that's basically the idea, is just implement a linked list. It turns out that the way that I implemented was with a doubly linked list, and here is my node class. I'm gonna go over this very briefly, but honestly my code is terrible, so I wouldn't recommend it, but hopefully the idea will get you to implement it. Maybe I gotta clean it up, but it's been a long day, and if you watch the live portion I explained it a little bit more. But yeah, but basically we have a couple of things. Lookup allow us to kind of just, this is just whatever, we have to keep the count of the key, and this is a reverse table, so that for each count give a set of keys, right? So that for each count we can get a set of the keys. Here, for each count, get a node containing it. So there are a couple of things you can do, by the way, but if I were to think if I did this more cleanly, I would probably merge this thing into the node by count by putting it into the node object. Maybe that would have been a little bit cleaner. And then you have the max, which is what we talk about. We just have to keep track of it, not a big deal. Min, we just have to keep track of it, also not a big deal. And we have a min head, which is node of 0. Actually, I don't think I ever used min. Now that I think about it, I think I used it at some point. So, but I think I actually deleted it. So we don't actually need this. I lied. Min head, this is 0 for whatever reason, but it's a sentinel. It doesn't do anything because everything's on the dot next. And we just set 0 to be self.head. Again, it's a sentinel. Here I have some weird functions, but we'll go over that in a second. So I have increment and decrement. So for increment, I always put if it doesn't exist, I add 0 to it, just so that it makes it easier to do the removal later. And then we add it. So we remove the old value, knowing that it is re, and then we replace it with re plus 1. So that's what these libraries or these helpers do. And this is my helper, right? Add and remove. And then I just go to add node, and add node is a weird function, honestly. It basically assures that re exists, or it assures that we want to transform re to re plus 1. So we want to make sure that re plus 1, we create re plus 1, which is what we have here. Or if it already exists, then we just merge it in there, right? And we also want to delete re if re has we has no object. Actually, this could have been also abstracted again. But yeah, if empty. But yeah, the difference is that, yeah, it's just a little bit cleaner, right? Yeah, so let's actually remove this real quick. So yeah, delete if empty of re, and we just kind of have this thing, right? Yeah, and you won't find this in the live portion because this is me also doing it live a little bit. But yeah, so that's adding, or that's incrementing. We add, and then we make sure that we add a node for re and re plus 1. Yeah, and then here we just we update max if we need to, meaning that if it's greater than max, then we update max. And then now decrement is similar, but the opposite, right? So re is the key. We always remove the key, and then because we decremented, we have to track that if we deleted. Well, first we track whether max changed, right? So if it's already max, or if the previous value is max, and now it has no count in the max anymore, then we decrement max. And then after that, if you subtracted 1 from it and it's still greater than 0, then we add it back into our data structures. And then we do this thing called subnode. It's basically the same as add node, except for it is the opposite, which means that we make sure that if re is empty, we delete it. but we also want to make sure that the previous node is v minus 1, right? Remember that this is a doubly linked list, so we want to make sure that the previous node is v minus 1, and we want to make sure that it exists. So if it doesn't exist, I guess current.prev cannot be none. I just kind of copy and paste this. But yeah, if the previous is not v minus 1, we want to insert it. That's what this does. And in this case, it's v plus 1. We want to insert it. Yeah. And that's pretty much it. Max key, we know what the max value is, so we just kind of look at keys by count, and we look it up. Yucky way of writing it. At min, well, it's going to be at self.minhead.next. If there's no values, then it will just be empty. But otherwise, this should always have a value. And that value, the x of it, terrible way of name. We just kind of look at it with the lookup key, and that's pretty much it. I'll go over the code again very quickly, and this is all of 1, right? Why? Because in the increment, add is all of 1. Add, we just kind of add things to a set and set a map value. Same for remove, except for we also delete it, right? And the add node is just this is all of 1, right? We add node and we remove node of empty. Let me also double check real quick, because we did make a modification. Yeah. Make sure that this gets accepted. Okay, because I don't want to lie to you. And apparently I did miss this sign. Right, so add node just removes node, and delete if empty. So basically, if the value of v is 0, then we just kind of remove the node. That's basically what this does. And we also remove it from the references. And this is also all 1, right? Same with this thing. It just add node and remove nodes. And yeah, same for decrement, right? We only remove, add, and this is all of 1, this is all of 1, this is all of 1, these are all of 1, and everything here is all of 1, given this weird for loop, because we return it from the first site. And that's pretty much it. Yeah, that's all I have for this one for today. You can watch me solve it live next, and yeah, it's a little bit yucky, a little bit messy, but hopefully this was pretty good. Or at least reasonably good, or at least you understand it and you can implement your own and be like, Larry's code suck, I'm gonna do it better. I hope you do. Anyway, yeah, you can watch me solve it live during the video next. Hey everybody, this is Larry. This is me doing day 29 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this one. Yeah, today it's been kind of rough. Just a lot of, yeah, ran 8 miles. I mean, that part's not the rough part, but just the Leetcode contest, I don't know, I got destroyed. Kind of was just sloppy and couldn't get my head right and wasn't confident. But I don't know, maybe today's this problem, it will be a good thing. So let's take a look at today's problem. 432, all 01 data structure. Design a data structure to store the strings count with the ability to return strings with minimum and maximum counts. All 1 initialize, increment the count the string by 1. What does that mean? If key does not, you have this key, okay. Insert of count 1, okay, dec, okay, that's fine. Get max key. Return one of the keys with the maximal count. Okay. Get min key. Okay. Yeah, I mean, I think you just have to keep track of everything. This is what I call a bookkeeping problem. And when I say bookkeeping, it's not like any particular algorithm. It's just you have to keep track of all the books. Like in like an accountant, you make sure that all the books balance and everything is kept track of in a good way. And that's really all this problem is. So yeah, so here maybe we have a lookup table, and that just to back all these things, right? We have so the key observation with this problem is that the max and the min can only change when we increase and decrease. So yeah, let's actually just write this out first. We increment by 1. If key not in self.lookup, self.lookup of key is equal to 0. You can maybe use default dictionary, but I think for this particular problem, I just want to be sure. It's guaranteed to exist. Okay, fine. So right, and then we can, if self.lookup of key is equal to 0, we delete it, right? I think the tricky thing is that Yeah, I mean, there are a couple of ways you can think about some of this, right? So max, well, max is a little bit easy, right? Because max only one of the keys, fine. Max only updates when yeah, max only updates when you increment, right? But if it decrements, maybe it gets a little bit funky. Let me think about this for a second. Maybe it's not as straightforward as I thought it would be. It is a hard one after, I suppose. At least to keep an O of 1. I think what I would have done if it's not O of 1 is that I would just use a heap, right? A lazy heap or something like this, and it should be fine. But okay. So what are the conditions of max, right? So when we increment, so we have a max is equal to 0, right? Maybe something like this, and then if self.lookup of key is greater than self.max, then self.max is equal to lookup of key, right? And maybe we have, maybe self.max keys is equal to an array, right? What would this look like? So then max keys is equal to just key, right? Else if this is equal to this, right? So you increment it and it's equal to, then we just append it to the max keys. Maybe. I'm not quite sold on this yet, but for now we'll do. And the reason why is because if we keep decrement, we have to kind of figure out no, I mean, I think, okay. I mean, I think the way that so if we decrement, we would just remove it from max keys. And then if there's another number, then that's fine. But I think the way that I'm doing this is a little bit sloppy, or like it's very potential for dubiousness. So we actually want to do like keys by count, right? And what this does is, this one I actually do want to use a default dict because we want to have a list. And then basically, max just gives us the max index. So if it's greater than max, then we just set max is equal to this number, and that's fine. We don't have to keep track of this, and we don't have to keep track of this. The thing is that then now, the keys by count, we do of self.lookup key, we want to append, well, there should be a set actually, not a list. So we want to add set, right? Yeah, or add key to the set, and we want to subtract it from the previous one. So yeah, right, because this is before we increment, and we want to remove it by key, right? Yeah, and then the max will give us one of them. And here, and just to make sure that this works, I think we have to do like self.keys by count. I mean, you could do it another way, it's not a big deal. Add key so that this could get removed, right? So this is for incrementing. This is the only time you get rid of max. There's something about the min part, but we'll just focus on max for now, right? And then now decrement, right? So then now we decrement, we want to also just keep track of this keys by count thing. So self.keys by count. If it's 0, then we don't care about it. Well, we have to remove it anyway, right? So we have to remove it anyway before the thing. And then here, in theory, we want to, if it's 0, then whatever. If it's not 0, then we want to put it into the new one. Yeah, because otherwise we don't have to remove it. We already do remove it, right? So then now here we have a data structure of keys by count that will give us the key for each one. And then now max. This should be straightforward. Well, no, not yet, not yet. So this makes it whatever, but then the decrement, right? So here, So the thing with max is that it can only go down monotonically, right? So that's the key thing. So what I mean by that is that max can only go down to max -1. There's no jumps, there's no gaps, because we're only decrementing. So then now we can say if self.lookup of key is equal to self.max, and we want to update max only if it's the left, right? If it's the only thing left, right? So then now this has remove a key. So n self.keys by count of self.max is equal to 0. Then self.max we decrement. I mean, yeah, because then now it would go down with this key. But so my worst case, or not just worst case, but my edge case is that if you have 2 or 3 numbers on max and then you go down one at a time, how would you handle it, right? So basically this just lowers the max by 1, and only the last one gets to shut the door, if you will, for the max. So that's basically the idea I have now. And then the max is just very easy to write. It's just that we have keys by count of self.max, and this is a set, so we can just I don't know how to get a random. I think you can do this, but maybe I'm wrong. I don't know. Let me do it real quick. Okay. Yeah. Oh, this is just wrong. This is 0. Whoops. Do I do set not? How do I get like the first thing, right? Is it just next? And does it always exist? Oh, it doesn't always exist. So let me double. I have to do some. Okay. So if is greater than 0, then we can just return the next thing, right? I think. No. Otherwise, we return empty string, right? Set is not iterator. How do I get a random thing? Get an item from Python set. Actually, maybe it's not. Oh, next we have to turn it to iterator. I wonder if that's over 1, because then you can also do a pop add, which is a little bit awkward, but I don't know. Apparently, there are a lot of people doing tool things, and apparently the cleanest way, which is ridiculous, is that for x in this, return x. I'm not even kidding. That's called key for this. So I don't know. All right, look. And then you could just maybe write it this way, which is ridiculous looking syntax. Right, let's see if that works. Okay, so that looks like it works for get max. Of course, the other ones is going to be wrong answer because we don't do get min. Okay, so now, so those are the cases for get max, right? So every time you increment, if it's greater than the max, you update the max. That's pretty much it. Okay, so what happens with min, right? Min is if you actually increase one, then that's always going to be the min, right? How do I start this infinity? Is that really good enough? Whatever, let's put it here. All right, wait. So then now we have if self.lookup of key is less than self.min, then self.min. I mean, which is kind of true. It's very funky, but the reason why this works is because it happens when you have 0 to 1, right? So that's basically the idea. If you have 0, you're going to 1, then this is going to be the case. But just like this, we have to keep track that, yeah, if before we subtract, I just it's just way, yeah. So if this is equal to min and self.keys by count of self.min, wait, what? This is a length, right? Okay, well, that's pretty bad actually. If the length of this is equal to 0, we increment it by 1, right? This is basically, again, the same idea. You increment it and all these things. And yeah, we don't have to care about the list because we just kind of keep track of it, right? But on the keys by count, so we're good. On the decrementing, well, decrementing is a little bit more interesting for this one, I think. Which is that, okay, well, if you decrement it, it's just, I mean, it's actually not that interesting. Just do this. So the only thing that's different is, I guess, this thing. And then now here we do the same thing, which apparently this is the cleanest way of doing it, which is funky. But okay. Okay, we have a wrong answer, which is cray. We still return empty string. If this is then yeah, that makes sense. This also makes sense. Yeah, this also makes sense. Oh no, well, no, that's fine. It's just that if this is the case, then this should be, yeah, I mean, this should be fine. Why am I, okay. Get increment, hello. So then what is the min here? Will we increment twice? So this should be right? Oh, this would never work because we haven't removed the key yet. So this has to be after we remove the key. The order of operations are tricky. I mean, I think this is fine, and then you do a subtract 1 because we already we added 1 here. Well, subtract 1's on this side actually. Oops. Yeah. Okay. All right. Looks pretty okay. Is it right? Honestly, I am so tired right now. I'm just gonna YOLO submit and let's go. Oh no. I just saw that last time I had 2 wrong answers, but also this time I also have a wrong answer. Oh, I'm just being lazy because this can delete, right? So of course. So what I need is this should be here. If it goes to I do have a mistake though. That actually I didn't think about. Or like I thought about it before I wrote it, but then I just forgot about it. Because basically here it goes from, if it goes from 1 to 0 on the, where's the min? Oh no, this is incrementing. If it goes from 1 to 0, then we have to handle this somewhere, right? And that also means that it previously was 1. So then now we have to figure out I don't know that I know how to do it, honestly. Okay, so basically here, yeah, we have to handle this case because then now this is 0, so then the min previously was going to be 1, right? And if the min was previously 1, then here maybe, you know, I mean, that's not even the whole, like we can maintain it and bookkeep it, but how do you get the second smallest? I mean, the idea. I think the idea is probably to use a linked list, but it's just such a mess. So annoying to use a linked list. Like if you have a linked list that allows you to point to the next smallest number, I think that's probably the way to do it. So then now when you remove it, like you remove the head, then yeah. If I don't want to do it, I think that's probably the right idea though. I mean, I guess everything should have been a linked list here. I just wasn't really was kind of lazy about it. Because everything is just shifting things to the left and shifting things to the right on a linked list, right? So not a... So you can add and remove stuff very easily. Is there another way? Let me think about this for a second. I mean, I guess like this is gonna be the way to do it. It's just so much bookkeeping. Satch. Yeah, I mean it is a linked list, but I don't want to do it. I'm just so tired today. Yeah. I mean this looks right, but then if you have something like well, there's no decrement in this altogether, but yeah, increment, decrement. Or just say increment, and then now we have increment, and then we just even increment or decrement. It probably would not work. I have to keep a string away. Did I miss one? Oh, how did I? Did it auto correct some stuff? Yeah, so you can see that this is returning an empty because self.min is probably 0. Okay, fine. We're 20 minutes in, I'm talking a lot. I mean, this is basically the idea is going to be, and I was thinking about this for a while, but I guess I just didn't get there, is that you have to use a linked list to kind of maintain the head, right? And then once you remove stuff, you okay, fine. I hate this. Maybe there's a better way, I don't know. But alright. Okay, so then now every time you create a new thing, well, we want to point this straight to the node too, right? So that we can this is just so annoying to do an O of 1. Yeah. Okay. Node by count. Right? And then now, so we have this thing, right? So that means that the node by this, so, and we want the previous node so that we can do stuff to it, right? Okay, so then, if we want to, if we increment, we get the node. All right, I have to, I think what I'm going to do is abstract this a little bit, because I think it's just too much to kind of do, right? So, okay, so let me rewrite this a little bit. Sorry, I'm just like very grumpy because this is such an annoying problem. Okay, so then now we want to say add self dot add the key 0, right? So then maybe we have def add self key value. I'm too lazy to whatever it. We have self dot lookup of key. We set it to the value. We want to say self dot keys by count of we want to add key, right? And then now we want to also do previous is equal to okay, so if key is in self.lookup, we want to delete or remove key value, right? So that's basically it. So then remove self.key value. We can do the self.lookup of key. So this is delete. And then here we have self.keys by count of remove key, right? So then now, okay, so then here we can so again, so then now we have we is equal to self.lookup. If it's not, then we do right? So then now v is equal to self.lookup of key. We want to add key v plus 1, and we want to remove key v minus 1. Oh, just v, right? So then now we get rid of these things. Or maybe just new v is equal to this, right? Yeah, that's fine. So then now, if v is equal to min, then we drag it up. But what we also want to do is we want to keep track of, okay, let's actually focus for a second, right? So here let's keep everything the same, right? We have v is equal to self.lookup of key, self.remove key v, and then self.add key v minus 1, right? And that's only if v minus 1 is greater than 0, right? So then now we can remove all of this, and then now we can and then okay. If v minus 1 is greater than 0 and v is less than self.min, then we want to do an update. Do we want to keep it the same? I don't know. Update min with self.lookup of key. Right. So max is actually we have to update that too. How do I think about this? What am I doing? So we're updating this to v minus 1, right? I guess we can also put this inside here to v minus 1. Well, update min is different because update min is the head, right? You only update maybe this is new min, right? I think that's a little bit better, a little bit different anyway. This is a new min. For the max stuff, I think we don't need to change it that much. This thing, we want to increment min maybe. And the max is fine, I think. So we don't need to do max. Yeah, let me run it real quick. Oh, yeah, of course. And here it should be self dot min head. Let's go min head. Min head dot next. Oh yeah, I don't have a next, right? Okay. Dot next. Dot x. I think. It's a little bit awkward because I'm thinking because this can be none, right? If there's nothing in it, so that's why it's a little bit awkward. If is none, we return right? Okay. Yeah. What an annoying part. Okay, so now we have two things. We have new min and increment min, right? But that's not it. I think the update max has no, not update max, but the add and the subtract, add and remove has to keep track of things too. That's why. So yeah, okay, that's why I have it here. Okay, let's do new min first, because this is just keeping track of whatever, right? So that means that current min, current min is equal to self.min head dot next. We have a new node, so node of v new min is equal to that's the name of the function, so that's gonna be confusing. But new min is equal to this, and then self.min head dot next is equal to new min, and new min dot next is equal to current min. Oh, I guess this is previous min really. So let's write previous min and current min. Right, and then we're good. And then what's the other one? Increment min. Increment min. Yeah, I didn't think there was a thing, but okay. Okay, that's fine. That's easy, actually. It's just current min is equal to self.min head.next. And then now we want to increment it. So then we have current min.x increment by 1. But now we want to check whether current min, so if this dot x is equal to current min.next.x, then now we just merge. That's basically it. Do we even need to? I mean, I think we do. Otherwise, your insertion sorts and stuff like that would get expensive or whatever if you keep on popping them, maybe. But yeah, so you merge. So if current min.next is not none, and this is the case, then we just current min is equal to current min. Oh, sorry. This dot next is equal to current min dot next dot next. So we kill the dot x, the next by merging. So we're good here, I think. Yeah, and I think I want to add a string thing. Right. Print self.x, and then if self.next is not none, self.next dot string. Okay. We move from v. So we have two places where you call remove, right? We remove from here. Unless there's something due to the min and the max. I don't think so, though. Okay, so wait, which one? 38 or 69? Nice. Okay, we remove. This should exist by definition. Oh, key by count. That could be a number of things, actually. I wish there's more way to oh, this is awkward looking, actually. Also, we don't use v, so we could do this, and then we just remove key. Oh no, we do use v, but we don't need to, because that's just yeah. Where's the other? Okay. Yeah, I don't know why we need it. I guess it's easier to do it that way, but well, that's not great. Increment and then decrement. Did the increment not put it? No, increment did. Oh, we added to 0, and then we look it up. 0, we remove, and then we add. Does add not work? No, we have it. Right? This is so annoying. Which one is it? 71. Okay. Oh, so this is doing the decrement. Okay, so then, oh, because we have this thing. I forgot to remove this. But then now this is after the. Yeah, now this is after the removal. But this is also wrong. Well, I mean, I guess if there's no object, then it probably is fine. But it could be just, if it is 1, it goes to 0. If self.max is 0, then I don't know, it just doesn't do anything anyway. I think that's fine. Okay, now it's wrong answer again, which is fine. We knew that. Okay, and then now we have to maintain the thing with the linked list, right? So okay, so we move solve that node. Oh, the node is of the one that's pointing to it. So removing it means that next is equal to something like this to remove it. How do you add? Well, it's a little bit awkward. I think I did this wrong actually, because I think we can just increment. But this is so stupid of a problem. I'm just having a tough day, I think. And I think the abstraction I did here does not make any sense. I mean, I think this is fine, but then here, now we want to so then V is the previous one, right? So then I mean, I think everything else is fine. I think I have to figure out how to update in a correct way. Okay, so then basically, okay, maybe I'll do a linked list check, right? Check V and V plus 1, I think, just to make sure that they still exist. And I think we're good. But if it doesn't exist, then what do you do? I think that's the problem. Right, so then now we have current is equal to what do I call it? No by count. Okay, so this is, and current.next should contain the node with V in it. So then now we check whether so incrementing means that this isn't quite right. I think we actually have to add first. I think that's maybe why, but it's a little bit awkward. Also, we do this twice, so I don't know. This is a little bit awkward in general. Okay, that's fine. How do I add? I think we always want to add before removing. I think that's the thing. Because if we try to add, the node by count is not going to give us anything, right? I think that's the problem. Okay, so I simplified it, but it's still a mess. Because okay, I think that makes sense. Okay, in this case, we added v plus 1, so we should be good, right? So then now we do naming things is hard. I just check v plus 1. So then now we have to make sure that it ensure exists. Add node of v plus 1. But it's from v, right? So then now I think that is maybe the thing. Because then now, okay, current node is equal to self.node by count. Maybe something like this, right? So then v, right? So then now this is the node pointing to v, and we want to make sure that v plus 1 exists at this point. So then here, if current.next, it should be pointing to v, .next is not none, and current.next.next.x is equal to v plus 1, then we're good. Okay, if current.next.next is none, then current.next.next is equal to a new node with v plus 1. Okay, and then we return. Right. Otherwise, it just means that current. I'm writing this in a way bad way, but otherwise it is not none, but it is not v plus 1. So then we just have to insert it, right? So current.next or new node is equal to node of v plus 1. Current.next.next is equal to new node, but before that we have previous node is equal to current.next.next. I guess that's fine actually. Previous node is the next, and then new node dot next is equal to previous node. So that works even if they're none. So that's why I said that's fine. And this is if we have no change, right? Okay, so we ensure that this exists, and then we now ensure. Okay, and then this is after removal. So then now we can see whether. So v plus 1 exists. We want to see if it still exists in v1. So then it's self.keys by count, right? Self.keys by count. So if the length of this is equal to 0, then we want to delete it, right? So if this is equal to 0, then current.next or current.next is equal to current.next.next. And also we want to remove it from the node list, which is this list, right? And I think we're good on incrementing node, hopefully. Or the add node anyway. I think I renamed it or something. Yeah. Oops. And then on the decrement, it's a little bit wonky because of this step. So okay, so I guess we just have to have an else statement. So then here we want to do we want to make sure that this is just terrible, but we want to show same idea, except for that we just yeah. So current is equal to self.node by count of v. And then if, no, because it's -1, right? So actually, I mean, yeah. The subnode is a little bit tricky. I guess we could have also used a doubly linked list. Maybe that's the way to do it, really. I don't know. I think, that, yeah, maybe I need to do a doubly linked list to do this in a smarter way. Okay, fine. Right. Self.prev is equal to none. Right. Okay. Increment min, so everything is fine, right? Yeah, this deletes the next node, but then now. So current min dot next dot previous is going to be wrong. It's equal to current min, right? Because this is okay. I think this is right. And then new min. I think this is the previous min is going to be the heads next. Okay, but current min dot previous is equal to self dot min head, right? And then add node. Yeah, this is fine. We insert a node. Right. Okay, so previous node. Previous is equal to new node. And new node dot previous is equal to current dot next, right? And if this is the v. If then we delete this node, or we delete next. So then now current dot next dot previous is equal to current. Yeah. Alright. This is terrible. I hate every part about this. 150. Huh? Oh, I have an else here because I never. Else. We just have to remove the node, right? don't know. Okay, let me think. I need to take a mental break for a second. Yeah. I mean, this is just bookkeeping still, but it's just so annoying bookkeeping. Okay, so here, documenting, we want to ensure that it exists for some. Oh, this is just updates the min. We don't really care that much, right? Probably not. Where's the new min? Well, this by definition is only if this is the case. Else we want to sub min or sub node or whatever of v, right? So we want to make sure that v does not exist and v minus 1 does exist, right? And this is where the previous will get us, right? So here, current equal this, right? So if current, I guess we don't need to do this current.next anymore as a reason because we have previous nowadays, right? So okay, let's step back a second again. I mean, I think this part is fine to keep a sentinel, but current min is the actual min, right? Okay, increment min is fine, new min is probably fine because we don't do .next, but then add node. Then now we want, okay, this actually points to a node, so then if the next node, we want to merge up the next node, otherwise, or the next node already exists for v plus 1, otherwise we create a new node. New node is this, previous new node, this is actually the next node, that's weird phrase. Next node is going down next. This is going, the next is going to be new node, next is going to be next node. And then next node that previous is going to be new node, and new node that previous is going to be current. And yeah. Oh, well, if this is equal to 0, we want to remove v, and current is the thing. So then actually this is just self dot previous dot next is equal to self equal to current dot next, and then next dot previous is equal to this, right? I think this is right. Yeah. Okay. If current.previous is not none and current.previous.x is equal to v minus 1, we return. Otherwise, we'll make sure that it exists. The previous node is going to be current.previous. Current.previous is equal to new node now. We insert it backwards. New node.previous is going to be equal to the previous node. And then now we have to set up new next nodes. Previous node.next is equal to new node. And then new node.next is equal to current, right? And then we have to ensure that v does not well, if it doesn't, only if yeah, if this is equal to 0. If this is equal to 0, then we have no more, then we have to delete it, right? Actually, these should be the same, so we should be good here. Okay. Sort that node by count. I guess this is probably true. For 0, I didn't really think about 0. Okay, so v is 0. Add node for 0. I don't know. It's easy to remove the head though, but yeah. we want to ensure that this exists. How do we handle 0? Oh, well, I guess it has stuff. So yeah, I think that's fine. So maybe solve that. No. Maybe an add we can do. Oops. What do we do for 0? Because it's easy to remove this by accident the way I wrote it. Just adding a node doesn't really change anything. But, if v is greater than 0, maybe then. And then now we can just do self.node by count of 0 is just equal to min head. Next node could be none. Oh yeah, because now we're changing it so that, okay. So this will be none and this is fine. But next node's previous. If next node is not none. I would also say that the reason why I'm so reluctant is because I don't really learn anything here. I think for a contest I would probably just do an log n thing, so that's why. Okay, current self.node v, and I've already been doing this for an hour for a problem that I was hoping to be quick. Okay, well, it happens. Okay, add node for 1. Oh, we created a new node, but we didn't update it. So, okay. So then now we create a new node. So node by count of v plus 1 is equal to new node. We also probably want to do that here as well, except as v minus 1, of course. Okay, I mean, at least it doesn't crash, which is nice. Okay, so we want to get max key, min key. Let's see. So get min key, we want to just print, print self.min head. Oh, yeah, I forgot. I had the thing, but then here. Oh no. Self.next is not none, right? Oh, is it supposed to return self.x? Okay, well. Okay, well, I mean, clearly this is very well. There are a lot of duplicates, but okay, we're getting somewhere, right? Okay, how do I do it so that what do we have? Inc. So print self.min head. I think here I forget to do something. Because here we subtract this, but we don't really remove stuff. But I guess if it's equal to 0, then it doesn't really... No, then you have to remove the 1. So we might have to do some removing here. Like we don't add, but we have to remove. something like that so that we don't add no, this. Or maybe maybe it's just whatever. If v minus 1 is equal to 0, we can just put this into the logic, right? Also, this is wrong, I think. Because it doesn't do this thing to remove the current node. So we add the node, but then we don't remove it. Let me just run it real quick. I think we're wrong, but that's fine. Okay, so we add. Is that that I'm printing too much? No, I think we're putting exactly the right amount. I think we are doubling this, right? Yeah, I think we're adding the right amount. I think the double is because we have added, we double add. Or maybe we just don't delete enough. So we increment. Hello, hello. Okay, so we increment. Okay, the new min is giving us issue. I think we don't need the new min anymore, actually. Maybe I'm wrong on that one. Because I think that gets handled anyway, so I don't think we need the new min or the increment min. And I think this neither. Yeah, let's get rid of these. Because now we implicitly do it. Okay, so 1, increment 2. Okay, increment 1. I mean, I think we're close. We took an hour, hopefully. So 1, 2. Yeah, increment, increment. Get min, and then increment again. I don't know if I'm printing too much, so oops, not here. So we can put a delimiter so that we can engage this a little bit better. Okay, so we do print twice. Is it only get? Oh, we do have it on get min key. That's why. Okay, let's remove that for a second. So every time we change, we get 1, increment 2. That looks good, actually. The second time, not so much. We're actually missing an operation even. Oh, I don't print on decrement actually, so I guess that's why. Okay, so this is definitely wrong. This one should get rid of the 1, which we probably have known that it is from here because this terminates early. So this. So okay, so if this is none or this is same with this. What's it called? Modus tonin? Or is it De Morgan's? I don't even know anymore. I'm too old for this. Too old for this. Okay, still no removal, but that's fine. I mean, it's not fine, but it's progression. I think the code still kind of works, which is great. Oh yeah, because it's this part. So then now it ensures that well, this only adds of this case. So then now we're subtracting, right, or removing, or we should be. Oh, this is an add node. We want it on the decrement. Huh, we don't call this at all. Oh, because we minus 1 is 0, but we still want to be. Actually, we don't even. Well, this I think we need it, but this I think I can put it here with the logic. Okay. This is annoying as hey. But I think we're getting somewhere, maybe. At least enough for me to kind of YOLO submit because I'm tired. Hopefully, come on. Oh no. Oh no. And also I forget to remove these things. But okay. Oh, current is weird. I guess that's not, we don't modify current. I mean, we do, but so subnode. Okay, we actually the print statement helps, but that's also what helps is if we just copy paste this. So okay, let's just assume that our other thing is fine. Okay, so we're subtracting 3, removing 3. Why? So we don't, the previous doesn't exist. It claims the next. Oh, I guess next could be none. Right. The previous next is equal to none. If current.next is not none. Can that happen with the other one? I guess so. I mean, I think that's just really bad doubly linked list things. I mean, on my part. It's like a very beginner mistake, but well, a very tired mistake. We did get it. So I mean, in the end, it's not so bad. But I think I just dragged my leg for a long time because I really don't want to do it. But yeah, but this is all of 1. I don't. Yeah, I mean, when done this way, it's you know, not so bad. And I think one thing that we also could have done is that we could have also put count in here. So let's actually do that as a yeah. So then we don't have to have this key table anymore. No, actually, that's not. You probably could do it that way, but I think it's just a little bit tricky to kind of keep track of all the keys. And I'm already tired. So yeah, how did I do that last time? Did I do it with linked list last time? I did do the next inter thing. How did I? Decrement. How does this work? I'm honestly don't know. With count. Okay, I mean this far is fine, but how do I keep track of the min? Oh, this is how I keep track of me. This is just wrong. I mean, maybe it's fast enough, but it's just wrong. I just keep on incrementing until I get it. You can imagine like in the worst case, maybe it passes for the input, but that's definitely not right. Because Yeah, I mean, it would, maybe this is n squared or something like this. But yeah, no, this is way wrong. I don't know what happened I did last time, but this is the right one. It's just about linked lists, right? Yeah, basically the idea is just to, like I said, bookkeeping, a lot of linked lists, and just adding and removing stuff. What we have here is a linked list by the count at the very end. And we just basically, the min is the head, and then we just kind of keep track of adding and removing nodes, and then the min head will give you the smallest number. That's pretty much it. Yeah, I mean, I'm gonna go over, I'll show you the code. This is the node class. This is all of one. This is my initiation. This is, I have helper functions. That's a little bit awkward, right? But basically this is, maybe make sure that v does not exist unless it has items, right? And v plus 1 does exist no matter what, because we're creating a new one. And this is the same thing, but v and v plus 1. Since we're incrementing into it. So yeah, so that's what I have. Yeah. So okay, so let's go over, so this is the, I don't know, I call it sub node. This is add node. I don't know anymore, honestly. Sorry, my friends. Yeah, but this is for adding a key and keeping track of these two things, removing a key, and then and I just kind of go through the cases for incrementing, right? So we remove the key, and then we add it to v plus 1 for the new one, and then we make sure that we call the add function, which allow us to, yeah, make sure that v, if it has at least one item, it should exist, and that v plus 1 should exist, or we have create a new node, and that's basically the idea there. Yeah, decrementing is the same idea, but looking backward. Oh yeah, the max part is easy because it only comes up when you need to increase the max, right? And when you decrement from the max, it keeps track of itself by this way. But yeah, we remove the key, and if it's greater than 0, we add the key to whatever the number is, and we also subtract the node again, or we make sure that v exists if it has to, and v minus 1 doesn't if it has to, and then that's it. Get max key, I just look at the first thing in the set and return it. Otherwise, if there's nothing, then we return empty. Same thing here. If the next is none, then we return empty. Otherwise, then the x value is the count value, so we just look it up from keys by count, get the key, and there we go. Yeah, that's all I have for this one. I think this video is terrible. My apologies. But that's all I have for today. I am so tired. I am going to take a break. So thanks for watching. Hope this was helpful, and hope you can see that Larry is struggling a lot today. So yeah, thanks. Stay good. Stay healthy to good mental health. I'll see y'all later. Take care. Have a great rest of the weekend, everybody. Bye-bye.